All right, today we're jumping into a huge shift in how our world gets built. It's so big, people are calling it a new industrial revolution. We're talking about the cyber-physical evolution. Okay, so let's start with a really cool idea. What if a factory could actually fix itself before it breaks? I mean, a production line that's so smart it can see a problem coming and sort it out on its own, maybe without anyone even noticing. Sounds like something out of a movie, right? But it's not. This is the big promise behind what we call Industry 4.0. So what is this Industry 4.0 thing anyway? What is the fourth industrial revolution? Let's cut right to the chase. So the official way to put it talks about a tight coupling of physical production and digital intelligence. But what does that really mean? Well, just imagine every single machine, every little sensor on a factory floor, all of it hooked up to some seriously powerful software and AI. It's all about building these huge connected systems that can see what's happening in the real world, figure out what it means, and then actually do something about it. It creates this nonstop loop of learning and improving. So if you remember one thing, it's this. We're talking about smart, connected, data-driven factories. This is way beyond just simple automation. We are now building factories that can genuinely think for themselves. They're all linked up. And maybe most importantly, they're always learning from this flood of data they create every single second. Right? But why the fourth revolution? To really get that, we kind of need to take a quick step back and look at how we even got to this point. It'll make a lot more sense when you see how it all builds on what came before. And this timeline lays it out perfectly. First came steam and water power. That was 1.0. Then electricity and the assembly line for mass production, boom, 2.0. Then in the late 20th century, we got computers and electronics, which gave us automation. That's 3.0. Each one of those was a massive, massive jump. But today's leap, Industry 4.0, it's a bit different. It's not just about getting a new tool. It's about making all the tools we already have intelligent and connected to each other. And that changes everything. Okay, so what actually makes one of these systems smart? What are the key ingredients? Let's break down the core building blocks. You can think of it like a chain reaction, really. It all kicks off with connectivity. You got to get everything talking to each other. Once they're connected, you can have sensing, gathering all that real-time data. That raw data then gets fed into the system's intelligence, where it's analyzed, turning all that noise into useful information. And that leads to autonomy, where the system itself can make its own decisions, like, say, rerouting a part or deciding it needs maintenance. But check out that last step, human centricity. This is so important. It's not about replacing people. It's about empowering people with these incredible tools so they can oversee the whole thing, make it better, and work with the system. All right, now let's get into the fun stuff, the actual tech that makes all of this happen. This is the digital toolkit for Industry 4.0. What's so cool is how all these pieces fit together like a puzzle. You've got your IoT sensors, that stands for Industrial Internet of Things, and they're basically the factory's nervous system, constantly sending out updates. That data often gets sent to something called a digital twin. And you can think of a digital twin as like a flight simulator for the whole factory. It's a perfect virtual copy where you can try out crazy new ideas without any real-world risk. Of course, you need super fast 5G networks to act as the backbone for all this real-time communication. And then you've got AI and machine learning acting as the brain, spotting patterns and making those autonomous decisions we were just talking about. But this isn't just some cool tech experiment. This has huge, real-world consequences for businesses, for entire economies, and for global competition. So let's talk about why this matters so much. And yeah, the data backs this up. The numbers are pretty clear. Studies show again and again that companies that jump on this technology see massive, tangible results. We're talking higher overall equipment effectiveness, which is a fancy way of saying their machines just run better and break down less. They can make things way faster, and they often do it all while using less energy. I mean, these aren't just small tweaks. This is a serious competitive edge. And you know what? This isn't just for the big, established industrial countries. For emerging economies, this is a massive opportunity. It's a chance to not just play catch-up, but to actually leapfrog ahead. By building things like sustainability and efficiency into their digital systems from the get-go, they can boost productivity and at the same time create better social and environmental outcomes. It's a path towards growth that's smarter, greener, and maybe even a bit more fair. And that really brings us to the big final question, doesn't it? As these cyber-physical systems get more and more autonomous, as they handle more complex jobs on their own, what does that mean for the future of human work? What skills are we going to need when the machines can basically run themselves? Now that is the core challenge, and maybe the biggest opportunity at the heart of this entire revolution.